Have you ever had an idea for a product, something that you'd love to bring to life, but you weren't quite sure how to start? Maybe you want to learn how to design it for yourself, but you have never used a CAD program before. If that sounds like you, then this video is the perfect place to begin. In this video, we'll take a complete beginner-friendly dive into SolidWorks, one of the most powerful CAD tools used by engineers and designers worldwide. I'll assume that you've never used SolidWorks before or any other CAD program, so we'll start from absolute scratch. If you already have some CAD experience, don't worry, we'll still cover some useful techniques and in-depth tips that might be new to you. Let me tell you where this all started for me. Last year I had an idea for a project I called the Lunar Orbiter lamp. It's a small USB-powered lamp with an onboard ESP32 microcontroller designed to light up every time there's a rocket launch anywhere in the world. So it's just a fun space-themed desktop gadget. We'll explore that full project in a later video, but for now we'll just use that as a real-world example on how to learn SolidWorks, from designing individual parts to assembling them into a full functional product. Before we begin, make sure that you have SolidWorks installed. If you don't have it already, please check the link in the description from my other video where I walk you through how to get started with SolidWorks Maker License. So just a quick disclaimer, none of these videos are actually sponsored by Dassault or SolidWorks. I've used SolidWorks in my professional work for more than 10 years, and I'm using SolidWorks Maker for these videos just to show you how to use it, and it's a cheap alternative to get started with a very professional software. All of the opinions in these videos are fully my own. So before we jump into SolidWorks, I just want to talk about 3D Experience, because there's different ways to work with SolidWorks. One is to work with 3D Experience in the cloud, or another way is to work locally in your folders. So in this tutorial, I'll show you how to use 3D Experience because it's really good for version control and so on. So in here in your content folder, you have your collaborative spaces. And in here, I've just created one called Lunar Lamp. You can create one for yourself and follow along. So when you first start up SolidWorks, this is what it's going to look like. You have this welcome screen and you have this panel to your right. So the welcome screen, you can get quick access to creating parts or assemblies or drawings, or you can open previous parts. And once you start working, you'll also have your recent parts here, so it makes it very quick to jump back in. You also have a few quick links here, which are useful to get help or search on forums and so on. And just looking at this panel here, we have different options in here. So here's the 3D Experience portal or synchronization tab, and here we can see the parts we've been working on in the past. Here's a file explorer for our computer, and here is a viewing palette for drawings. Here's some appearances, custom properties, and design library. So just starting off looking at this one, the 3D Experience, you can go up here and click on this cog. And if you go in here in credentials, you'll see all of your collaborative spaces. So I already went ahead and created one called Lunar Lamp, and we'll just select that one and we'll click Save. And that changes the workspace for us. So before we get started to actually design some parts, let's just stop and think about what we're actually doing. It's often a good approach to just take a notepad and just draw down what you're trying to build and just try to keep it simple. Think about the parts that you want to put together and what the functions of the part should be and how they're going to look like and so on. And also, very importantly, how it's going to be assembled. So let's have a look at this example. And this started off as a little sketch on my notepad, and it turned into another sketch. And before I knew it, I had the basic concept of what I wanted to try to build. So I knew that I wanted to have a radial LED panel in the middle, kind of. So LEDs that are shining all the way around. And there should be a transparent kind of tube around that. And then also, I was thinking about the shape. I wanted it obviously to look like a rocket inspired by Tintin, the cartoon, and also by SpaceX, the rocket that can land. So I brought those inspirations into my idea here and came up with this kind of general concept of having a rocket shape with 3 legs and also a little kind of flame. So I thought it could be really cool to have this flame be transparent and then also have a LED inside. so that when a rocket launches somewhere in the world, and this will be connected to the internet, it'll do a little flame, so, and then light up the whole rocket. That would be pretty cool. So just looking at this design and thinking about it as like a sketch as well. We've got this middle part, we've got like a cap on it, we've got a middle section where we want to have some dials on it, and we have like a kind of interfacing part, and then we have this kind of plastic part. So all in all, it's about 5-6 parts. And so we'll start off by drawing up this tube here first, and then we'll move on to looking at the other parts and how they relate to the tube. Another quite important aspect when you're first thinking about drafting up a product or an idea is to think about the scale of it. It's really hard to actually gauge what size the objects have in CAD, because the size is just whatever you zoom into, right? And it's often surprising when you design something that you just had a sketch of and in your mind, and you actually go to have it 3D printed or built, and you kind of think that it was going to be smaller or bigger. So just try to get a physical reference of your object. And in my case, I was thinking about 30 centimeters tall. I would like to have it. So 30 centimeters. And then I was just thinking about the legs, maybe, I don't know, 10, 15 centimeters. So that gives us kind of like a cylindrical box shape that this should fit into. And we can use that later as well when we start to draft up things. So now let's try to have a look at creating our first part. You just go up here in the top left corner, create new. In your case, it might be looking like something like this. You have part, assembly, and drawing that you can create. You can also click here on advanced, and it'll give you the same options, but it also has another tab here for 3D experience. So that's basically the same templates, but these are online in your cloud, and these are local on your computer. And templates are basically a kind of a start arena for your parts or assemblies or drawings. You can make a new template yourself by just opening a part, changing whatever settings you would like to change, and saving it again as a template. And then next time you open it up, you have the right settings that you like. An example is units. So if you're working in imperial units, you can change your part document settings for that, and so on. So let's create our first part here. So this is what it's going to look like when you first start up a part. Now you have this ribbon up here, and you have different tabs in the ribbon: features, sketch, markup, evaluate, MBD dimensions, lifecycle and collaboration, and add-ins. You also have your part tree over here, and you have different tabs up here: properties, configurations, and appearances here. Here in the left hand corner you have your reference planes. So these are basically, as you can see, you have a top plane, front plane, and a right plane, and everything you draw will be referenced to these. We'll put them on so that you can see them. You can see how they intersect in the origin. So we also have an origin there that defines our 0, 0, 0 coordinate point. Then up here we have some quick tools. So these are just for, navigating. And here's a section view. This will actually cut your part in half or whatever section you like, just so you can see inside and analyze. This is just a quick orientation, your cube. You can also get that by just clicking a space bar. And that's really handy for just getting a good orientation view of your part if you want to look at it exactly from the side or something like that. To get home to your view, you can click Control 7 on your keyboard, and that orients it in the kind of normal isometric view. Up here you have different display states. So once we start drawing, you'll see that the shaded with edges is kind of the normal view, and then you also have shaded, and you have just hidden lines removed, hidden lines visible, and wireframe. And these can be useful for different things, like if you want to have a look inside your part without like cutting it in half, you can actually use these, and you can see the lines going through and so on. It helps you see potential conflicts within the parts. Here you have your view panel, and you can hide everything by just clicking on the eye. You see that the planes that I otherwise had shown are now disappeared because they're excluded from the view. Click it again and you activate all of the views here. And in here you can just select them one by one. For instance, if we don't want to see the planes, click there, and so on. Here we have edit appearances. So once we start working with assemblies and parts, you can give them different appearances, and that'll also be useful later if you're working with SolidWorks Visualize. The appearances will kind of carry over and you can work with it easier there. This is your scene. So if you want to have white background for some reason, you can just change the black here. This is the default. Up here you have different graphics settings, so perspective, ambient occlusion, shadows, real view, and we're going to have a look at that later, cartoon as well. Moving over here, we already talked about these fields here. This one has changed now that we're starting to work with a part. It has discovered that we have a part created which hasn't been saved yet, and yeah, it's just letting us know that. Other than that, you have obviously your normal toolbars up here where you'll find properties and save and so on. Edit is normal, and these are different view settings that are also very useful. Toolbars you can set up however you like up here, and insert is very useful. Here you find features that you don't normally find up in your ribbon, so they are more like advanced features, stuff like that. You also have tools here, so here will be sketch tools that are useful, and again it'll be usually tools that are not visible in the ribbon. Well, they can be visible, but some of the more advanced will be removed from the ribbon to make it easier. And then you just have views here, so you can have, for instance, if you have multiple windows, you can have them side by side and so on. Oh, and by the way, if you're working on a dual monitor, you can also span the display there. However, the toolbars don't carry over to the other display, so that can be a little bit annoying. You also have an option down here, like you only have the kind of basic ribbons to start off with, but there's actually heaps more. So if you go in here, you also have sheet metal, for instance, and that'll pop up like that. We can work with that later. There's also mold tools, all this other kind of stuff, surfaces. Let's quickly talk about these different concepts here. So when you're working with a part, you have features, and these features are basically based off a drawing. You'll make a first 2D drawing and you can extrude it just like this, for instance, or you can revolve, and it's very neat how they show you here what it actually does. So that's very helpful. And the things that are grayed out are stuff you can't do right now, and usually because we don't have a sketch right now or some other condition. So what's a sketch? So a sketch is just a 2D drawing, and it's a 2D drawing that you can then use later to make a 3D geometry. And I'll quickly show an example of that. So let's just create here in our box, and it asks us to select a plane, and we'll click the top plane here. We'll just hover over our origin like this and draw a box like this, simple. And you go up to the right hand corner, click OK here. Now we have a sketch of a box, and now we can go back to features and click extrude, and this will give you a dimension to extrude. You can also grab this one, however it's a bit fiddly sometimes, but you can use that. And then there's which way you want to extrude it to. Do you want it to just be blind in one direction? Do you want it to be up to a vertex, a surface, offset from surface, up to a body, or midplane? So in general, when you're designing, it's very good to have your center of origin in the middle of your part. And that's usually because if you export it to another software, it's easy to reference the part's origin. That might not be always true. It depends on what you're drawing. So if you're drawing something that you want to reference at the base of it, for instance, then I would just do like this. So now we have our origin in the base of this cube. But generally, if you make like an enclosure or something like that, I like to have the center of origin in the middle of the part, because then our split line will be down this plane, which will be really easy to manage. So now that we have a basic geometry, you can see that a lot of the features are now unlocked. So let's go through them one by one. You usually start with a extrude or a revolve. So that's when you don't have any geometry. And these you can also use to create new kind of starter geometries. These all here are like modifiers, so to speak. So if you want to make a hole, you need to have an existing geometry to make a hole into. And if you want to make like a specific kind of hole, whether it being a thread or a press fit or a drill size, so on, you can use this one. And if you want to have a specific revolved cut, that's where you draw something and you want it to cut around an axis. You can have a swept cut. That's basically when you have like some sort of line and you want it to cut a profile that follows that line. Or lofted cut, and that's when you have like two different drawings. Let's say you have a square on one side and a round on one side. It'll do a transition between the two shapes. And the boundary cut, that's when you have a boundary that you draw and it can cut through that, basically. Up here are like some different kind of modifiers. Fillets are very common. They basically just smooth off the edges of your part, like this. And we use them all the time basically to give it a nice non-sharp edge. We also have chamfers. If you click on the arrow there, and these are used a lot in CNC parts to break the surface. Or if you want to create something more interesting to look at, I use a lot of these chamfers just to make basic shapes. It kind of breaks the sharp edges. Up here you have all of the different pattern options. So patterns are really useful if you have some geometry you want to repeat again and again. So as it says here, linear pattern. Let's say we have like a little hole here, or we have some geometry we want to repeat in one way or the other way or both. So I'll give an example. Let's just do a little circle here. We'll extrude it up by 0.5. Now we have a little circle extrude here. I want to repeat that. So we click on linear repeat. We can click on an axis. And we say the distance between them should be, let's say 5. We want 5 pieces. And let's say I also want it to go the other way. Click that. Click the same distance, maybe. And we also want 5. So you see how it can pattern in the two directions. And they're very useful for creating repeat geometry. I'll just delete this. And likewise, you can also repeat in a circle pattern, or you can mirror. So actually, let me just bring back this one. Let me show you how to mirror. So mirror is also very common and useful. And mirror, it mirrors around a plane. So you always need to have some sort of, imagine a mirror that you have it around. So in this case, it's going around this plane. And let me show you, if we choose a different one, how it actually works. I'm going to hold down Control while I select this plane and the edge, and I'm going to drag, and that creates a new plane reference to this. And I want this new plane to be, let's say, 5 millimeters away from this plane. I'm going to click OK. Now we have a new plane that we can mirror around. So let's try to mirror that pattern around this. Just clear this. Oh, sorry, that's already selected. Click up here. So this, by the way, obviously when you're working over here, you can't see your model tree. Well, you could go back here, but then you can't select the thing you need to select. So SolidWorks pops up the model tree over here. And sometimes due to graphic glitches and stuff, it won't pop up. But if you move your mouse up here, it'll actually activate it and it will come back. So it asks us now what plane do we want to use to mirror and what features do we want to mirror. So we can try the feature, we want that one. And now you see it's mirroring around that. So before it was over here. So that's how that works. Delete this one, delete this feature, and delete this sketch. And these are more advanced kind of patterns. This one is sketch driven, so you can have different dots and you can have a table even, or a surface area you want to fill out with geometry and so on. These are different kind of modifiers again. Shell is also often used when you want to have an enclosure, for instance. Now we have a box. Let's say we want to have a wall thickness of 0.5. Click Show Preview, and it'll show you how the shell is going to look like. Let's try to change this. 2 millimeters. You see the wall thickness is now thicker. And this field here is for whatever surface you want to remove when it creates a shell feature. So let's try to just create it without removing anything. It looks the same, right? It's just a cube, but it's actually hollow now. And we can see that by using this section view up here. So this section view, as it says in the name, it cuts a section, and you can control where it cuts the section like this. This is section 1. You can rotate that as well and drag it. And if you want, you can create another section, and you have some starting points here. Say you want to create a section that way, then you can section 2 ways, and you can flip it as well. So this is a very useful way to look into a part. Click cancel. We still can't see inside now, but there's another way to see inside. So up here we have the display part, display state, sorry. This is now by default shaded with edges. You can also have shaded, and that's just removing the edges. You can also have hidden lines removed. This might be familiar from an IKEA manual or something like that. And you can have hidden lines visible. So now you can see inside, and it shows you the actual hidden lines inside. And this is also useful for when you're working with a part and you want to actually select something, because how do you make a fillet inside a part if you can't see the edge you're trying to select, right? So here you can click there, click fillet. So see, now you can create a fillet inside. So that's very useful. Let's go back to the shell feature here, because we skipped this one thing, and that's you can remove a face as well. So this one, you can select which face you want to remove, click OK, and you see it removes the face there. You can also do multiple faces if you want. So it's very useful to create a basic geometry first, and then you can create a shell to make an enclosure, or in this case, a post-it holder. So now that we've covered the basics of creating parts, let's try to create our own first part for the lamp. So go up here and click New Part. And for this part, we'll draw the cylinder for the lamp. So it's a hollow cylinder. I'll draw on the top plane to do a vertical cylinder. And I'll just draw a circle from up here. I'll take my dimension tool, and let's say it's 35. It's more like 45 millimeters. But the dimension is not actually that important right now. It's just important that it's in the ballpark, and we can always adjust that later. I'll show you how to do that. Click Escape and click on the line, and then we use this offset entity to create a wall thickness. And I'll just reverse this to make it internal. And we'll say a wall thickness of 2 millimeters up here in the parameters. So this gives us the basic shape for our cylinder. Now let's extrude this. And we'll say about 185. So now we have our first basic part. I'll just hide these again. And now let's save this to 3D Experience, to our workspace, or collaborative space. And we'll call this cylinder. And now sometimes it does this where it hides the save button even though it's actually valid. Might just take a moment, but sometimes clicking through these might make it work. So now we've saved our first part to our collaborative space, and going over here, opening this window, we can see that it's actually synchronized with our cloud system now. So we can lock this now. And now let's try to make another one. Let's try to make the cap of the lamp. So if you remember, we're trying to do a rocket lamp, and it has like a kind of a dome shaped cap, and that would be hollow, but it would have kind of like a curvature shape on the outside, and then it would kind of interface with the cylinder. So for that, I'll use a revolve, and we'll use the front plane because we want to do a revolve around this axis, the y-axis down here. So let me try to do that so you can see. So I'll do sketch and click front. I've already started a sketch now, and I'll draw a center line from our origin up and double click to stop. And so this just drew a line that we want to revolve our feature around. And in the bottom we have kind of like a step like this. So imagine our hollow tube that we just drew will be kind of fitting into like a little groove here. Do it like this. And then we will do our dome, and for that we'll use a style spline. So I want it a little bit sharper, so something like this, let's say. Maybe you can start to see it now. You can see this is the cross section of the dome, and as we revolve it, it'll kind of become a complete dome. So let's try to implement some dimensions. You see that some of the lines are black and some of the lines are blue, and when they're blue, that means that they're not fully defined, meaning they don't have a dimension, and you can kind of grab and drag it like this. And generally that's not good. You want to have all of your sketches defined, otherwise they can kind of move if you change a dimension or something happens, the model can kind of fly apart. So it's always good to kind of lock that down. And for this, let's say, I think we said that the outer dimension was 40 from memory, or was it 45? 45, let's say. We can always change that later when we get to assembly. So the way I did that was I selected this outer diameter that I want to select, and then I clicked the center line and I dragged over. Let me try to do it again so you can see it. Center line. Oh, sometimes it just snaps like this, and it knows that you want to do a diameter like that. And let's also do constraint on the top of it. Let's say 40 will do for that. And let's try to do a inner. We said the wall thickness was about 2, so we want at least 2.1 so that we have some clearance for the parts to fit through. And let's do some overlapping geometry of 3. So this will be however much material goes down into the other part. We'll see that later. This line, which defines this spline, we can hold Control, click this line, and hold Control, click this line. Now what you see is you're getting something called relations. So these are very useful, and we use them all the time. Basically to define how does this one relate to this one without giving a dimension. And for this one you could either choose make vertical, because vertical just means up and down, or horizontal means right and left, or you can make it collinear, so that means they should be aligned, these two lines. Perpendicular, as the name suggests, parallel, or equal in length, or fixed. So in this case, I'll just use collinear, and you'll see it kind of snaps in. So now these two lines are aligned. You still have some blue lines, and sometimes it can be a little bit tricky to see what exactly is not defined yet, especially when you're first starting out. But if you just drag onto those lines, and you can kind of drag in each direction, you can see that it has a freedom to move in only one direction, up and down, but not left and right. And that's because we've defined now this line should be in line with this line, so it can't move these ways. It can only move up and down, but you can still move that point, which is related to this part of the spline. So now we can define this to define the curvature of the spine. Let's just say we want this to be 45 degrees. Or let's say 60 degrees from this angle. There. So now you see there's still something blue, and I had a hard time just figuring out what was that, but it's this one here, as you can see when I drag it. So we'll do another dimension and say this should be 3. Another thing we can do, depends on the situation, but instead of writing a dimension here, we can just say that this should actually be the same length as this. So we just click one line, hold Control, click the next line, and then we get this menu here, and we can click equal. So now I'm just saying this should be the equal length of that, and that saves us one dimension. But it also means that if I change this to 4, you see now this one also changed to 4. So it depends on what you're doing and how they're related if you want to do that. So now we have a open kind of sketch. It's not closed here. It's open in these directions, and that's how it should be when you're doing a revolve. So now let's try to revolve, and we'll just get rid of these planes for now. They're a bit confusing now. There. And we click this line, that's our revolve axis. Click revolve, and it says, would you like to close it? Yes. And so here you can define how far should it revolve. Do you want 180 degrees, 90, so on, and that you can like use for different purposes. Obviously for this case we want 360. I'll just show you just so you know, like if we do 120 for instance, it'll take 120 from the plane and then around, but you can also do here mid-plane for instance. Now it does 120 around that middle. So that can also be useful in some situations, but we'll just select blind and 360 degrees. So there we have it. This is our dome for the rocket. But as you see, it's solid, and we didn't want that. We want it to be hollow. So let's try to use the shelf feature for that. Show preview. Let's say we just want it 1.5. And let's try it. It didn't happen anything. So let's have a look. And that's because we still have the bottom. So to remove the bottom, you just select the surface you want to remove. And there we have it. So there we have the dome, and now it's hollow. Now this would be fairly difficult to machine. Let's say we want to have it machined CNC. We have a step inside the part, which is not easy to remove. As you can see here, if you were to move it, how do you get in there? So one way to kind of fill out the part, which is useful for you later as well, we'll just take this section view so we can see what we're doing. I'm gonna select this surface in here. Because what I want to try to do is I want to basically extrude or fill this surface, this internal space here in the right. And one way to do that is just to create a sketch that has that area, but extruded that way until it meets this geometry. So I don't actually need to draw up another circle and another circle to do this. I can actually use the existing geometry, and we already have a flat surface here that we could use as a drawing plane. So let's select the surface and click Sketch. So what that did now is it kind of creates a temporary plane that we can draw on, because this is a flat surface. And now we're drawing on this surface, so we can select this inner circle and this outer circle, and we just create convert entities. And now these circles are actually linked to the model. So you can see that they're fully defined, they're all black. And that means that if this geometry changes, these will follow. And that's exactly what we want. We don't want to have to come back and change the dimension if everything changes. So now what we can do is just extrude this. So extrude. And this is not what we want, right? We want it to come up and meet this geometry. So what we do is just click blind first, so you can see which direction it is, and then up to surface. And then we can click the internal surface here. Click OK. And now you see it's filled the surface in here. So that was just a good demonstration how you can use existing geometry with a sketch and then use that to your advantage. So now it's actually able to be machined. But now we have this sharp point here, and we don't really want that. We want it kind of be a little bit more blunt. So let's go back and change that. So here we can see that this kind of curvature goes up into a point, but what we actually want is to have it more like flat, like this, when it kind of joins up here, and then we can define the kind of the flatness of it. Or maybe even better, let's think about this. Maybe even better, we have like a round nose. So imagine that it's kind of forms part of a circle here. And let's try to do that. So let's backtrack a little bit, and you'll find that once you start drawing parts, you'll do this as well. You'll go back and forth and figure out how things should be drawn up. So it's quite a good example here. Now let's try to draw this circle. So I'm just drawing, I know that I want part of a circle. I don't want a full circle, but let's try to draw this up first, and then I can show you the trim tool. So let's try to get our spine. And now I want this one to be tangential to this. And that means this should be coming off this circle kind of, so that it kind of runs in smooth with this and joins in. So we need to clean this up obviously, because we only want the circle from this point to that point. So what you can do is use this trim tool here. And this basically trims any kind of section of the line that is in contact with other stuff. So if I trim it like here, it will basically cut away from that point to that point, which is what we want. And now again, if I cut from there, it'll cut away the rest, and that's exactly what we want. So now you see we lost some of the references we just did, and sometimes that just happens. And we just put them back in. 25, and let's make this one again in line with that. And we'll give this one up here now a radius, let's say 5. And we'll say again, this one should have an angle of 55. And you can see when I changed the dimension just then that it actually shows you what that's going to be looking like. And that's also very useful. So, oops. Obviously I couldn't change it to that big of a degree, but 45. So that didn't work either. And that's a good example of basically the SolidWorks error kind of response system. Anything that turns yellow, it can't resolve. So that means that the dimensions it would have to be are not kind of valid with any geometry that could exist. So you just click OK and Control Z, go back. There we go. So we're back to the start. So everything's fine again. So click again. So another way to kind of play with the geometry is, now that you don't have a dimension, you just drag it. You see what does it actually change. You see that it changes here. And that also actually tells you something else. We thought that we had the tangential continuity, but we don't, because it can actually break in these two lines. You see it goes like that. So this is another way to check that your model is drawn up as you were expecting by just dragging the blue lines. So let's click on this one and click on that one again. Want to be tangent. And you can see now that they're tangent, it's actually satisfied. It doesn't need another dimension because that dimension is now defined by these two being tangential. And it'll update the shape once you click OK. Okay. So now we've made changes into the geometry here, and you can see something is wrong here. And that's because whatever reference we had before no longer exists. So that's because we deleted some lines, we put in some new lines, and the resulting geometry is no longer the same like in the background. The surface here will have a specific ID, and that ID is now new. So now this one can't find out where should we actually draw this feature, because the face is different. So sometimes you have to go back and repair things that you've done when there's bigger changes, but in this case it's fairly straightforward. Let's have a look. So it looks like our drawing itself is fine. It just doesn't know where to start the drawing. So you can see here, could not find end face for feature. So to fix that, we just right click here and we click the sketch plane. And we say here, actually, let me correct myself. That was not the issue. So the issue was it knows where to start. It knows this plane, but it can't find out where should it extrude to. So let's go back in here. And that's that face there. And it kind of makes sense because that was what we changed just now. We changed this geometry. So we just click, that's the face we mean. And now it's happy again. Hide this. And this is kind of like a sharp edge. I like to add fillets to any sharp edges. It makes machining easier. And also if you're 3D printing, it's nicer. So we'll create a fillet internally here. 15 works like that. So that's the cross section. And when we assemble this with the tube, we can add a little chamfer here. Let's say 0.5, that's enough, and it just helps with aligning this part to the tube. So now this part is pretty much done. Let's save it. And let's check that it's saved properly. And we see that it's saved properly. If you made it this far in the video, thank you so much for watching. I hope that you learned something, and congratulations on getting started with SolidWorks. This is just the first step in getting started to actually make your product ideas a reality. And we have a lot more ground to cover, obviously, but this is enough for just the first video. In the next video, we'll have a look at how to bring these two parts together in an assembly, and then also make in assembly context parts. And that's pretty cool. So if you like this content and you would like to see more, please support my new channel by subscribing or liking the video, and I'll make more for you. Thank you so much. Have a great day. Bye.